Okay, we are back with our faithful C128 on the bench. After the repairs and a little bit of upgrades, it performed admirably, with one exception, and that's this socket here. These are the old Commodore single wipe sockets, and every now and again it didn't want to boot. The ROM just wasn't making good contact in there. I'd wiggle it around or whatever, and it would fire up. So we're going to pull the socket off. We'll put a good socket on there, and something else I was thinking was there are more than 2 option ROMs out there. There's quite a few of them. I found some of these 8-in-1 ROMs that were for sale for a while, and now they're not. Maybe the guy sold out, did a batch of them, and that was that. I saw a couple on eBay for like €100, and they're way over in Europe and very, very expensive. So I got to thinking, how can I do this with stuff I have laying around the house? So we're gonna pull this ROM out. We'll put him aside. Maybe I'll give it away to somebody who needs one or whatever. It absolutely works as long as you have a good socket to plug it into. We'll swap this socket out on there, like I said, and then this is a 256K chip. Yeah, 256K, 2 megabit, and I put some of the round pin headers on there to kind of act as a standoff. And this is a 32-pin chip as opposed to a 28. By and large, the pinouts are the same with the exception of where the power pin is and the couple of added address lines to be able to deal with having more memory. So we are going to stack this in here. We're going to add a couple 3 resistors and a little jump wire for the 5-volt and an Arduino to do all the dirty work, much like Adrian did on the 64s, and I largely plagiarized his work, and I guess it's not plagiarism if it's open source, but we're going to do an 8-in-1 kernel ROM on this, or option ROM on this bad boy, and we ought to be able to have pretty much anything we ever want to do with it at that point. And also have the ability to just unplug it when all is said and done and just have a clean slot there to play with other ROMs, or just undo it if it proves to be a pain in the ass for any reason. So first things first, I got to get this old junky socket out of here, so we're going to swap him out and then start wiring up the new ROM. Alright, our shiny new socket is in. We burnt a ROM. This is pretty cheap. One-time programmable, so hopefully I got the ROMs right where I want them. And basically all we did is take a bunch of 32K ROMs, space them all out. 8 times 32 is 256, right? So we have our 8 ROMs programmed on here, and so this chip has 4 extra pins, and then the pins right next to the 4 extras, if you want to call them that, we also need to do some funny work with. So put it on some single round pin just to stand them off some, to give us some room to work and make sure things don't short where we don't want them to. And at the end of the day, he will just be able to plug right in with some pigtails coming off of him, going to our Arduino, or you could do it with toggle switches too, if you don't want to do the whole Arduino thing. But having a rotary switch or a pile of toggles hanging out of the back of the computer is kind of a pain in the butt. So I figured we'd expand on the Arduino kernel switcher project, and I'm thinking this guy, he ought to be able to fit in right about there. We'll double tape him down to the board. That'll give us plenty of room to tie into him for programming, and all the address lines that are going to have to tie back into the chip to do the toggles for us. So with that being said, kick over to this screen, so hopefully my mouse pointer comes out in the recording, but here's our 6 pins that are hanging off the edge now, right? Or I'm sorry, on this side, here's our 6 pins that are hanging off the edge now. So as you can see, these chips are largely the same, right? All the data bits and most of the address lines, all the way up to really all the way up and down this side of the chip are all the same until you get to the power pin that's hanging off the end. On the other side, it's pretty much the same, and we have our address line 17, which we're going to have to play with hanging off, which is why I've left off these 2 in the little pin header standoff extension thing, whatever you want to call it. So we don't care about pin 31. That's just used for programming. This is a one-time programmable, and I could just rip that pin off the chip and it ain't going to matter because you're never erasing this chip anyway. We're going to have to do something to get our power where we need it. You know, our VCC is going to be hanging down the end here. You know, so pin 28 is going to have our 5 volts, pin 32 hanging out the end. So we'll do a little feed from 5 volts somewhere into this. It doesn't necessarily have to come from the socket; it just has to come off the 5-volt line on the board somewhere. So we'll find the best place for that. Maybe we'll take it off one of the caps on the board or whatever. But we'll feed him his 5 volts. We're gonna have to put pull up resistors on address lines 15, 16, and 17 because that's what we're going to use to do our toggles. And by that I mean, let's see if we can see all this stuff here. So when we toggle each address line, right? You know, 15 is basically going to toggle in, you know, the first 32K offset, you know, to get you down to the second ROM burnt to the chip. When we drive 16 high, it'll bring you to the third one, 64K down. But then to get to 96K, you're going to pull 15 and 16 at the same time. So I've got my my little map here of when everything's low, you know, we're not offsetting the memory register and the ROM chip for reading. So it's going to be the first ROM, which is burnt to the chip, so that's servant. When we drive A15 high, it's going to go to the second ROM on the chip, which is the GEOS 1581 ROM, so on and so on, moving on down the list. So the Arduino code is going to control all of this, and we'll just have to tack these 3 lines into the Arduino in order for him to be able to have a good conversation with them. So we'll stop recording here. I'm going to prepare some wire and resistors, and we'll get back to you here in a few. Alright, we're at stopping point number 1 here so we can test some stuff. We have the ROM in place. We have 3 pull-ups coming off the, you know, the last pin, the hot leg, your 5 volts, going to each of the address lines, 15, 16, and 17. So I think it was 15, 16, 17? I gotta look at the map. Okay, yeah, so 16, 15, I'll get a little pointer. 16, 15, and 17. So right now they're all connected to 5 volts. We just have a little jumper lead coming off 5 volt in the socket next to it. This is just for testing. We'll figure out a cleaner way to do this. And ground coming off that socket as well. So now that we're driving all 3 address lines high, according to my little cheat sheet, based on how I wrote the ROM to the chip, this should be the diagnostic ROM, the Commodore diagnostic ROM. So we fire him up, we go right into diagnostics. So now we got built-in diags, and till we do something else, that's all the machine's gonna do. So let's see. So 17's an easy one to get at. If we bring 17 low, that should bring us down to the 96K offset. I can't do the hex math in my head, but basically the third bank of 32 within this chip. So we'll ground him, start him up, and we should get KDOS. Yeah, look at that. Now, if I had a keyboard, we could really boot into the ROM, but I'd say that's a good sign. So what happens if we short 15? Where does that take us? It probably takes us to an address we're not actually using. If I remember correctly, 15 low won't take us anywhere we care about. Yeah, now if we go these 2 low, 15 and 16, see if we can wedge that in there. That should take us... Alright, with 17 high, 15 and 16 low, we should get Super Chip A. Well, that's another one you gotta hold down a key to get to it, I think, so... Alright, what if we just do 16? I gotta look at all the keystrokes for these, but alright, so 15 high, 16 and 17 low should get us Geos, which we're not going to see on this display either. But no, I'd say we had 2 successful tests. Short of me getting a keyboard and an 80-column monitor, I think that's the best we're going to do for now. I'm going to continue to wire this guy up, and I think we'll have a winner. Alright, we're about halfway there. We'll stop for a little break here for dinner and whatever, but Arduino stuck down to the board. There's a big 5-volt bus bar, this trace down here, that big fat trace. So that's I ohmed him out. There was 0 resistance between him and 5-volt on the ROM socket, and 0 resistance between him and the power switch. So that's definitely a power rail there. As big and fat as it must be anyway. And similar down here, big ground rail all right through in here. So we got our ground coming off an empty via there, and there was an empty via there for the 5-volt. 5-volt for the chip, I just took right off the bottom of the socket, you know, the fat part of the round pin socket. So you know, you can completely remove this thing from the board and pop in another ROM if you wanted to or whatever. But completely undoable. We're not destroying anything here. And then I took our 3 address lines, 15, 16, and 17, and hooked them up respectively to 5, 6, and 7, just to keep my sanity when I go to try to impersonate a programmer and write some code for this thing. So we'll stop here. I'm going to grab some food and read some schematics to figure out where I can pick up the restore key. I'm assuming that's going to be somewhere on the other side of the board. And the reset line, I'm sure, is going to be back on the user port slot there, just like on the 64. And the XROM line, which on the 64 you grab out of the PLA. I don't know if you necessarily need that one here, because we're not screwing with the kernel. So we might try this with just the restore and reset lines. So hold down the restore key for a few seconds, the light will blink, it'll go into reset, and pull whichever address line low we want to pull low. So, yeah, I got to do a little bit of homework. I don't know the layout of this board too well, and we'll find some cool places to pop in for the restore line and reset lines, and I think we'll be cooking with gas then. All right, here's an update on the hardware install here for the Super Mega ROM Switcher 9000 or whatever we're going to call this thing. But we're doing well. I found that you don't need the XROM line. It seems to do just fine with holding reset down for, I don't know, about 500 milliseconds is all that's in the code, half a second. And I've been able to cycle through all the ROMs, looking good there. I don't have the blinky light quite down yet. Some of them look a little spastic and nuts, but I guess that's just par for the course with this basement anyway. But I'll play with the code a little bit tomorrow, see if I can clean up the lights so it actually works pretty, you know, looks uniform when it goes from one to the next. So we have, again, our 3 lines going to 3 address lines on the ROM, on the other side of the pull-up resistor from 5 volts. The black line here turns into a purple line here, and goes over to, what is that, R23 is right next to the reset switch. I thought if this computer was engineered with an actual reset circuit in it, we'll just come right off the switch there. So it goes basically in parallel with the switch, then through the resistor and on through the network to actually reset the CPU. So it's protected by whatever they designed the circuit to act like to begin with. And then the restore key I found comes in on pin 3, goes to cap labeled EMI 37, and then after that cap it comes over to R9 over here. So I thought that'd be a good place, have the cap as a little buffer between the you know, between the actual keyboard and the Arduino that way, I guess. But seemed just like a great place to pick it up. On the other side of the resistor, I guess it goes on down the line to probably the timer somewhere, or probably some logic gate and then the timer, I think. If it's anything like the 64, I think it hits logic and then the timer. So, at any rate, we have restore, we have reset, and it works really well. Again, power line still hooked up. And then one more thing I did for extra credit, I guess, was actually hook up the light to the power light, which is pretty cool. The power light on the 128 is actually 2 LEDs on this little board here. So I was able to take one line and keep it on the 5 volt that comes out of the board. So half the LED is on with power, and the other half blinks when the Arduino does things. So I just have a couple little breakout leads here. One of them comes from the status light on the Arduino. The other 5 volts comes from the board, and then I just have it grounded right to the board there. So it a little spaghetti-ish, but tell you what, it works. And then lastly, I thought it was kind of silly this computer had a caps lock and a shift lock. And I know they're slightly different, but I barely use either one anyway. So instead of having a dangly switch hanging out of the back of the case for the kernel ROM to go back and forth between Jiffy and the stock kernel, I just tied it right into the caps lock switch. So now when caps lock is out, it is Jiffy DOS, and if you need to defeat Jiffy DOS for whatever reason, you can hit the caps lock key, send it a reset, and away you go. So less gangly stuff. When all's said and done and you put this back on here, you won't see anything. No holes, no wires hanging out of the side, no extra LEDs, none of that. So I think that'll look pretty cool that way, kind of the sleeper. So yeah, I think that's it for now. I'll play with the code a little bit tomorrow, see if I can get the blinky lights blinking right, and we'll shoot one last video and wrap it up. Alright, so we're back here for a little wrap up. The machine's running. We're running diagnostics now here. We'll kick over to the list. So this is the way the ROMs are laid out in the switcher, and just so happens these are the order they're written to the chip. But you can really mix and match. You can change these use cases around if you want them in a different order. I mean, that's just the way it came out, all by random sheer luck. So we're on diagnostics now, so that's case 7. So that would be 8 blinks because we start numbering at 0, right? So we'll kick back over to there. We hold the restore key. Here's our 8 blinks. Then 1 blink. We let go, and we're back at ROM number 1, which on our list was the servant. And I'm not going to sit here holding the restore key so everybody can watch. That's just kind of ridiculous, but you get the point. You hold down restore. The first time it tells you what ROM you're on. The second blink cycle will tell you the next ROM you're going to. So it just counts in order. And you could screw with the code to make it do different things if you want it. You know, 1 blink for reset, and then each time it just tells you 2 blinks, I'm going to go to the next ROM, and then you just count that way, you know, if you don't want the light blinking spastically all the time. So, sky's the limit. These things are really easy to play around with, and that's that. So, I guess we'll wrap this up for now, and I'll have to get to work on the video mods. That'll be the next video. I don't want this thing getting too long. So, thanks. I hope this helps somebody, and get in there and solder some wires to your old machine. Take care.